Okay, hopefully you see how this works out, but it's just going to be integral from 0 to infinity t cubed e to the negative st dt. By letting u equal t cubed, you know that your integral is going to have a multiple of t squared. And by letting dv equal e to the negative st dt, you know that your integral is also going to contain v, which is a negative e over s, e to the negative st over s. So this equals you're going to get 0 for the first part of the integral, because you're going to have a product of t, which is 0 at 0, and e to the negative st, which is 0 at infinity. So it's going to be a t cubed here, but other than that, it's the same term. It's still going to give you 0, always going to give you 0. Anytime you want to go up by a power, you're going to get something here that has that power of t with an e to the negative st over s. It's also going to be a negative, but it's going to be 0, so none of that really matters. Okay, then you're going to have plus. It's going to be plus because it's minus the integral of v du, but the v is going to have a negative because and a derivative of e to the negative st. It's going to be I'm going to put the 1 over s out here. I could have done it here, right? And it's going to be times 3. We don't need a new word. Yeah, it is. No. Okay, 3t squared e to the negative st dt, which is something wrong with that. Never mind, nothing wrong with that. 3 over s times the Laplace transform of t squared. If you take that 3 out, you have the Laplace transform of t squared. I was wanting to get 6 here, but of course I do when I multiply it by the Laplace transform of t squared. 3 over s times 2 over s cubed, which is 6 over s cubed. Okay? Now, what are you going to get for the next one?
To the fourth.
Yeah, if you do t to the fourth, what's going to happen?
No, I mean it's s to the fourth.
Oh, yeah, okay, sorry.
My bad.
Mine. Okay. Right?
Right.
What's going to happen if you try to do t to the fourth?
It'll be 24 over s to the fifth.
Yeah, you're going to get a 4 from the derivative of the t to the fourth, right?
Right.
Okay? So let's just kind of trace where we get this. Okay, Laplace transform of t is 1 over s. The Laplace transform of t squared is 2 over s times Laplace transform of t, right? Which is then going to be, I'm going to write this as 2 times 1 over s squared times Laplace, times, well, just, that's it. Okay? Laplace transform of t cubed is going to be 3 over s times the Laplace transform of t squared. Okay? So that's 3 times 2 times 1 over s cubed. And the Laplace transform of t to the fourth, you're going to get a 4 over s. For the same reason, you got a 3 over s here and a 2 over s here, right? It just comes from your u substitution. And that's going to be 4 times 3 times 2 times 1 over s to the fourth. So what's happening here?
It's just like a factorial on top, isn't it?
Huh?
It's like a factorial on top.
Yeah, you're getting a factorial. So what's the Laplace transform of t to the n?
And factorial over s to the n. Or, yeah. Yeah, you're right.
Okay? Look in your book.
S to the n plus 1.